Hello, ladies and gentlemen. This is Dr. Robinson, and today we're going to continue our studies. We are talking about compound events. Compound events consist of two or more events. So we're talking about two or more things or activities that we're going to be doing at the same time. Independent event is the occurrence of one event that does not affect the probability of the other event. Please note that the probability of two independent events is equal to the probability of the first event times the probability of the second event. The accounting principle explains the reason why we multiply. Dependent event. If the occurrence of one of the events affects the probability of the other event, that is a dependent event. So we're going to deal with independent events. So here we have Anna tossing a cube with the faces numbered 1 through 6. And she's going to spin the spinner below at the same time. What's the probability of tossing a number greater than 2 on the cube and red on the spinner? So we got to get a number greater than 2 and red on the spinner. All right, well, let's look at the cube. So we're looking for a number greater than 2. What numbers are greater than 2? Well, we got 3 right there, 4, 5, and 6. Those numbers are greater than 2. So out of the 6 numbers, there are 1, 2, 3, 4 numbers that are greater than 2. Now we got to get the spinner. Now the first thing I notice on the spinner, there are 4 sections. And what's noticed really good, the colors. There are 2 colors I see, but most of the colors are red. Out of the 4 sections there, 3 of them are colored red. So there are 3 out of 4 sectors that are red, and that's my probability of getting red. So now the question is, now that I got these 2 fractions, what am I going to do with them? Well, I got to multiply because they're both independent of each other. So I'm going to multiply these 2 fractions to get the probability of getting a number greater than 2 and the probability of red. So when I multiply them, 4 times 3 is 12, and 6 times 4 is 24. So my answer is going to be 12 out of 24, and that reduces down to 1/2. So the probability of getting a number greater than 2 and a red sector would be 1/2. And notice my answer, probability number greater than 2, 4 out of 6, probability of red, 3 out of 4, probability of red and a number greater than 2. We have 4 6 times 3/4. That gave us 12 out of 24. And 12 out of 24 is equal to 1/2 when we reduce it. And by the way, it's equal to 50% if you change it to a percentage, or a decimal, 0.5. So nice question. Here's an independent probability question for you about a young lady, Thais, tossing a quarter that she got from Johan 5 times. She wants to know what's the probability of getting 5 heads in a row. So there's a nice question. See if you can get it. We'll talk about it tomorrow. Check your understanding so far. See if you understand the video. If you don't, turn it back, watch it again, and write down your questions. I'll be glad to answer them. So let's try a little bit of different probability event where we have marbles this time. A bag contains 1 orange, 4 blue, 3 yellow marbles. What is the probability of drawing a blue marble followed by a yellow marble in that order without replacing the first marble? So let's see. What's the probability of drawing a blue marble? Well, how many blue marbles were there? 4 blue marbles. And how many marbles were in the bag? Let's see. 1, 5, 8. So 4 blue marbles out of 8. So the probability of getting blue was 4 out of 8. Now, it said something about without replacing the first marble. So if you're going to take out a blue marble, then that means that's going to leave you with one less marble in the bag. And it's going to be 7 marbles left in the bag because you took out one of the blue ones. Now, we're looking for yellow marbles now. Well, how many yellow marbles are there? 3. So since there are 3 yellow marbles left in the bag, because we took out one blue, we can now use our counting principle, which we'll talk about a little later, which tells us for compound probability we have to multiply these fractions. So 12 will be our numerator and 56 will be our denominator. So our answer will be 1256. That was a pretty good question. So let's review. The probability of the blue was 4 out of 8 because there were 8 marbles, 4 of them were blue. Probability of yellow was 3 out of 7. Why 7? Because remember it says without replacing the first marble that you took out. So now that leaves 7 marbles, not 8, and you're looking for 3 yellows. So any 3 of the yellows are due, so 3 yellows. Now the probability of getting a blue then a yellow, well, you multiply the probability, 4/8 times 3/7. That'll give you 1256, and that also reduces down to 3/14. So that was a very good question. So I hope you got something out of it. Here's a question for you to try. Again, has one orange marble, 4 blue marbles, and 3 yellow marbles. So you're looking for the probability of drawing a blue marble followed by a green marble in that order without replacing the first marble. So that's important. So think about it. That's a pretty good question. So check your understanding. See if you can get it. Remember, write down your questions. Here's another question that you can try to see if you can get it again with an orange marble, 4 blue marbles, 3 yellow marbles. What would be the probability of drawing a blue marble followed by an orange marble in that order without replacing the first marble? So I hope you found the lesson easy and that you got something out of it. So remember, write down your questions. If you have concerns that you want to talk to me about in the morning, I'll be glad to answer them. So it's been good talking to you once again. So keep watching our videos. We thank you for giving the likes. So take it easy. I'll see you in the morning. This is Dr. Robinson signing off.